Hello, good morning, good afternoon. So, yes, hello everybody. Welcome back to another fun-filled adventure, fun-filled, exciting episode of COMP1511 18s1 lectures. So, I hope you've all had a good weekend and your toots and labs are good last week and this week if you've had them so far this week. Is the volume okay? It sounds sort of feedbacky. Is it tolerable? Can you hear me okay? Raise your hand if you can't hear me. Oh look, no hands. So, thanks again to everybody who had feedback for me last week. This is sort of the most common things that I got. So, one request was that I upload the lecture code, so the code I write after the lectures. Surprise, I did already. You can get that on the course website. I'm going to try a thing this week where I actually write the code in the place that you can get on the course website. So whenever I hit save on here, you'll be able to get it on your computer. Oh yeah, if it loads. Are you guys all trying to load the course website and slowing it down for me? Man. So there we go, lectures, and then week 4, lecture code. So then you can hit view in browser to get a nicer view. And if you go parent directory, you can get all of the weeks. Otherwise, week 4, Tuesday, live. And this is where I'll put the code I write today. So again, course website, lecture section. Okay, another request was to put the diagrams in the lecture recordings because the diagrams are great and then the lecture recordings don't have them. I will try my best. I should be able to edit them into the lecture videos because I've been recording them on the tablet when I draw them. So there's going to be lots of drawings today. I'll try very hard to get those in. And again, more diagrams. Today's got lots of diagrams. Hopefully that'll be good. One thing a couple of people have suggested, and I struggled to put it into words, is when there's a really complex program we've written and then we write it and then we run it, that's a bit confusing. So when it's all finished, just sort of step through again, going, this is how it all works, and then run it. So happy to do that. And one request I hadn't thought of is subtitles for the lectures, because I talk really fast, and maybe with a very slight accent. And I realize YouTube does automatic subtitles, so I'll make sure to put my videos on YouTube, and then you can get the automatic subtitles. Hopefully that will work. Cool. After today's lecture, and again, topics don't actually know how to do all of these, we will be able to hopefully you'll be able to write programs with nested while loops. So we looked a bit at those last week. We'll look even more at them this week. Understanding how to stop loops using loop counters and sentinel variables. We're going to look at something awesome, cool, and new called arrays. So you should understand the basics of arrays. And then if we have time today, if not probably tomorrow, looking at sort of the approach you can take to design a solution to a problem. Cool, admin stuff. Don't panic. How many of you are feeling panicked because it's week 4? Actually, how many of you had week 3-itis last week? Like you just got kind of sick and felt terrible? Only a few of you, yeah. So kind of week 3, week 4, right? The uni stress is starting to build up. You know, not quite doing, shh, be quiet. Uni stress is building up. You're not quite on top of things. Don't panic. Life is good. Life is good. Lecture recordings on the course website. I'll add the diagrams and put them on YouTube. Style guide, please read it. The weekly test from week 3 is due on Wednesday this week. How many of you have done the weekly test already? Okay, cool, that's most people. So if you haven't, on the course website, it's self-invigilated 1 hour long. So set a timer yourself. We're not gonna watch you on your computer. No access to your own code, the internet, or any of that stuff. It's an opportunity for you to find out if you actually understand the material. So if you cheat on this, we won't know that you'll fail at the end of the course, basically. Cool, next up, assignment 1 is coming soon. So I know assignment 1 was meant to come out last week, I think. But the good news is the assignment was almost ready. I have seen a draft of the assignment, and tomorrow we'll be talking about it. I'm talking really fast, my apologies. And one more thing that we might not have mentioned enough times, we have help sessions or help labs, which are where I think they're almost every day each week. And there are some tutors there who are lovely people, and they can help you with any problems you have with the lab exercises or course content or setting up your computer or anything. So they are under help sessions, if the course website loads. Well, you can just believe me, they are under help sessions. No, okay, I give up on waiting. We can look at that later. Cool. And so, thinking back to last week, we have, what if we want to do something multiple times in our code? What do? We use a loop. And so loops are keep doing this thing while this condition is true. The structure of the loop, the anatomy of the loop, we have our initialization where we set up our variables, condition, while something, statements, the things we do in the loop, update, move to the next iteration. Hopefully you know this. If you don't, keep this in mind. All of your loops will have this. So every time you write a loop, you start with int I equals 0 or something. You have your condition I is less than n or something. At the end, you have the I++ or something. And then in the middle, you have the contents of the loop. So all of your loops will look like this, mostly, probably. Cool. And we looked at ways of stopping loops using a loop counter for a start. So to print out hello world n times, where n is chosen by the user, we scan a num while I is less than num, I is I+1. So like I will start at 0, become 1, become 2, all the way through to the number they gave us. Cool. This is called a loop counter. And then we also have sentinel values, sentinel variables or flags. Some flag while something is not something, do some stuff, and then if the something becomes something else, stop. More specifically, in this case, the user enters a number, we print out whatever their number was, and if they type in 0, then we stop. And so this is some code we wrote last week. We also looked at nested loops, while something, standard while loop, and inside that, another while loop. And so an example of that is this one here. Nice normal while loop here. While j is less than n, print some exclamation marks. Around the outside of that, we have another while loop. So we do this while loop this many times. Cool. Is that all good so far? Super quick. Speed through. Cool. And so we'll be looking at using this stuff more as we write code in the lecture as part of the other things we're doing. Okay, looking at variables. Hopefully you all feel pretty comfortable with variables. Ints, int I equals 5 means we have a box. They can hold a value of a certain type. So int I equals 5 here means give me a box, put the number 5 in it, and call this box I. Oh, that's not all going to fit. So in our programs, we can make as many variables as we want, right? Like there's no limit on, aside from the limit of your file has to be small enough to fit on your hard drive, right? But we can have lines and lines of code making all sorts of variables. I is 5, age is 18, pi is 3.14, and each of these becomes a box with some value in it that is used or that is stored with that name. And sometimes you want to store lots of related values or similar variables. So for example, if we were looking at doing statistics of student marks, so we wanted to look at all the marks that the students got and take the average and say, in this case, this code that goes off the end of the screen, what? I can't scroll it. Computers are hard. Hopefully that's sort of readable. So to work out the average of these 3 marks, we have to add the mark together and add the other mark together and the other one, divide it by 3, and then that's the average, right? If we have 3 students, sure, we can do that. We can have 3 variables. There are 1,160 minus 36 students in the course at the moment. So I don't want to be making 1,160 minus 36. What's that? 1,124 students. I don't want to make that many variables. But what? It looked beautiful on my computer. I'm sorry. So pretending that this diagram wasn't broken, we have this thing called arrays. And so variables are like one box, right? We have int I, this one box that's a variable. An array is like gluing a whole bunch of boxes together. all of some common type, all next to each other in a row. This slide was meant to go before that one, my bad. Yeah, okay. Anyway, so the boxes, we number the boxes. So for some reason, we start at 0. So this would be like box 0, box 1, box 2, box 3, box 4. The numbers don't really line up. I will draw a picture on the tablet soon. And again, a reason to do this from before, if we were trying to calculate statistics of many, many students, we'd need hundreds of variables. Ha ha ha, there's thousands of students in this course now. So instead, we use an array. So what that means is, instead of saying like int mark, like we would do here, right? Make me a variable called this of this type. We say make me a variable called this of this type, but actually glue this many of them together. So like glue 1,160 of them together. And then we can put values into them by doing this. So rather than saying like mark equals 85, we say in the variable mark, in the 0th box, or the first box, put the number 85. And then mark 1, 90, mark 2, 45. And so on. Let me just check what I have in my slide next. Cool. And so when we have an array in C, we refer to it as a collection of array elements. So the elements are like the individual boxes. They must all be the same type. And we refer to them by their index. So if we have an array of size n, so size 5, for example, it can hold the elements are 0, 1, 2, and 3, and 4. So from 0 to n minus 1. And there's not really a limit on the number of elements. The limit is the memory in your computer, basically, the size of your hard drive. So no limit in reality. We can't do things like assign, scan, or print a whole array at once. We can't just go scanf into my array, all of these numbers at once. We need to do things one at a time. Okay. And so with that brief rush through, hurrying through all of this array stuff, let's write some array code. Have any of you not used VLab yet? If you haven't, you should. It's amazing. I'm going to say that every time I use VLab. If you could go back in time to when we didn't have VLab and we had to do horrible things to get our marking programs to work. Kids these days. Okay, and so as I promised, this 1 week for Tuesday live. Nope. So if I make this beautiful C program that's not actually very functional, can you see it on your laptops if you try to do that? So if you go to the week 4 lecture code thing, go to Tuesday, go to live. What? Curtis said that wouldn't happen. What do I set my UMask to? I did. Oh well. Let's try that again. When I make a thing called array, okay, computer, you can do this. Go to Tuesday, go to live, go to the file. What? I thought UMasks were meant to solve this. Help, you have lied to me. I'll just set the permissions manually each time I make a file then. Like all other things in life, I tested this at home and it worked just fine. So, there we go. We'll need to quit and restart gedit. Okay, have I been lied to this time? Are the tutors right? Will it work? Yes, array.c. So you can follow along with the code that I write in this folder from the course website. And again, computers, right? They're fantastic things and they're very hard, except for when things work. So, beautiful program. Comment up the top. What's the date? 20th. Cool, so here is our blank program. Remember, so making a normal variable, right? Hopefully you are very happy with this. Cool, so I've made just a normal variable called I. It is 0, and I'm going to print it out. Cool, so we have established that I can write basic C programs. Cool, so then I said before we can make arrays, right, by having the number of things we want to be glued together as a number we give here. So with this syntax here, like this stuff here, call it array, I've made an array of ints that will hold 5 ints. We can't just do this to make it be equal to 0, like we can do with normal ints. Yeah, there we go. It's saying you can't do this with arrays. So we'll leave that for now. And we can't print I because I doesn't exist anymore. If we try to print out array directly, warning, you can't do this. I can do whatever I want, computer. So we've tried to print out the array, and we've gotten this number negative something. Something I may or may not have mentioned, I say things like you can't do this in C. C actually is happy to do whatever you tell it to do, right? You can tell it, hey, print this array as a number. It won't print out the array as you want it to, but it will print it out as a number. And similarly, if you don't put a value into a variable, you can print it out. It'll have some value, it just won't do what you want. Anyway, let's put some numbers into this. Let's put the number 10 into it. So the syntax here, what I've done, I've said in this thing we have called array, at position 0, put the number 10. And then to print out the thing at position 0, it's like if this was a variable called I said I equals 10 and printf I. It's the same thing there. Cool. We have achieved nothing that we couldn't already do with ints. But that's okay. I'll grab my tablet and draw some pictures. Okay, so yes, record the screen, very good. I know some people have said that the diagrams are really helpful, so I'll sort of do the diagrams side by side with the code that I'm writing. Okay, so I've got my int array 5, which means I've made myself 5 boxes that are glued together. There we go, that's roughly 5 boxes. And so then this is called array, that's the name of it, and it's holding things that are ints. So when I say this syntax here, array 0 equals 10, that is putting the 10 into this thing, which is the 0th position of the array. So then those are the numbers that we would use to refer to the elements, 0, 1, 2, 3, 4. Cool. Is this all going well so far? If you are completely confused and everything is terrible, please raise your hand. Okay, one person is honest enough. Let's keep going and hopefully things will make sense as we go through. So to put a value in this box here, It's at like position 1 of the array. So I say array 1 for the index 1, position 1, equals 20. So let's put 20 in there. Cool, so it's just like normal ints, but instead of having their own separate names, we refer to them with the one name and then the numbers within that block that they're in. So this is still kind of like limited though, right? We can type in these numbers by hand, but we'd still have to type in, 1,000 grades if we wanted to type in 1,000 grades. So if we want to do something multiple times, what do we use? Anybody? A loop, yes, thank you, person who was paying attention. So how would I make a loop to go through my array and set all the values in the array to be something? What are the 4-ish steps that I need for my array? What's the first one? Any ideas? Have you all learned actually nothing at all in the entire last week? Yes, initialize. How do I initialize my loop? I think you said something like int I equals 0. Is that roughly what you said? I can't entirely hear you. But yes, we do need to initialize our thing first. So for a loop, that looks like int I equals 0. Then we have while something, do something else, and then we're done. So what does this thing at the end always have to be? I++, very good. What is the difference between I++ and I equals I plus 1? Nothing, very good. What is the difference between those and I plus equals 1? Nothing, very good. We prefer doing I++ because it's more clear that that's what it's doing, and it's harder to make a typo. Like if we type that accidentally, right, that would not make it be 1 more, that'd be 2 more. Cool, I++. What do we want to do inside our loop? We want to print out the value of the array, right? Or let's set the value of the array. So I said before that to set the 0th element, I did this. What do I need to change in here to set the ith element, or the element I'm up to? Someone said change 0 to something. I'm going to guess I said change 0 to I. Yes. Cool, and so what this will do, what should my condition be here, by the way? How many times do I want to go through the loop? 5, yes. So what this is doing here, when this runs the first time, I is going to be 0. Cool, so we've started our loop out here. We're up to this line 13 of code, and we've said I is 0. Now we're saying while I is less than 5, well, 0 is less than 5, so we're good so far, array I equals 10. And so because I is 0, this means array in slot 0 equals 10. Cool, and so then I put 10 in slot 0, that's already done. I++, I is now 1. Is 1 less than 5? Yes. So this is going to put array 1 equals 10, which will be that line of code there, which will do this. Now we have 2 10s in the array. Very good. I++, what is I going to be now? 1 plus 1? It's 2. It's not 3. Why are you saying 3? I'm pretty sure it's 2. Cool. I is now 2. Is 2 less than 5? Yes. Did you say no? Go back to kindergarten. Don't you learn counting in preschool, kindergarten? Anyway, 2 is less than 5. Yes, very good. You've passed primary school. In array slot 2, which is this one here, we put the number 10. I++, I is now 3. Is 3 less than 5? Spoiler, yes it is. So then into slot 3, again, we put the value 10. I++, I is now 4. Is 4 less than 5? I hope so. Into slot 4, put the number 10. I++, I is now 5. Is 5 less than 5? No, 5 is not less than 5 because it is equal to 5. And so our array stops. We've done the check is no longer true, so we skip past all this and go to the end. And then in this case, we'd print out array 0, which is hopefully going to be 10. So let's run this and see. Cool, it's just printed out 10. I'm going to do a thing. Cool, and now in this folder, it will be that folder so that it's less space. That was black magic, just ignore what I did, it's fine. So running array gives us 10. Cool, we haven't established anything more, we're still just printing out the one number. But what if we want to print out the numbers multiple times? What do we need? A loop, yes, thank you. So if this, if this loop here sets I to be 10 multiple times, what would we need to do? Apologies. So if this loop here sets the value to 10, what do we need to change in here to have it print out the value? If we want to print something out, we need a printf, right? All good? Print out a number. What are we going to put in this slot here? Yes, array square brackets I. Perfect. I'll delete this line here. Okay, and so what is this going to do? What do we want this to do? We want it to print out all of the array elements, right? So 10, 10, 10, 10, 10. Is it going to do that? Does anybody think it's not going to do what we want it to do? People with your hand raised, why? Yep, reset I. Is that an alarm or like whistling? Okay, I woke up this morning to fire alarms in my apartment. Living on campus is great. Highly recommended. So what's going to happen here? This is not going to do anything. And to prove that to you, I will run the code. Because you should never trust what anybody says, you should always try it yourself. So running array has just printed out 10, so it's done nothing new compared to what I did before. The reason for this, remember how we walked through this loop here before, and we got to this point here, and I is 5, right? I was 0, then 1, then 2, then 3, then 4, then because it was 5 we stopped, and we went to this point here. I is still 5, I hasn't stopped being 5. In this bit here, we set I to be 0 before this loop, but because we haven't set anything different here, I is still going to be 5, and so nothing is going to happen. I is, and to prove that to you, I is 5. So in order to make I not be 5, and in fact be 0, you can type these wonderful words, I equals 0. Cool, and now it prints out all of the numbers. I is 0, prints out array I, so array 0, which is 10. I'll just walk through this again. So I is 0 to start with. 0 is less than 5, print out array I, so print out, highlighter, this one here. I++, I is now 1. I can't draw with a highlighter, oh well, you can just believe me. Whoa, that does not control Z on that. So, yep, I is 1, look at array element I, print it out, it's 10, I is 2, print it out, print it out, print it out, and so on. Then at the end of this loop, I will be 5 again. We print out array 0 again because we had that already, and then we end our program. So this is still kind of boring though, right? We've just set everything to be 10. We could have just had while I is less than 5, printf 10, right? You wouldn't be able to tell the difference. What's something more interesting we can do? Any ideas? What's a more interesting number than 10? 10 plus I, very good. Cool, and so now this has given us 10, 11, 12, 13, 14, 10. The last 10 is because of this one here, which I'll get rid of. Let's try that again. Cool. And so looking through our code again, while I is less than 5, so I is 0, it's going to make array I be 10 plus 1. So array index 0 be 10 plus 0. Cool. I++, I is 1. Array 1 is going to be 10 plus 1, which is 11. I++, and so on. So we've got the values 10, 11, 12, 13, and 14 in our array. And then we print them out. Cool. Is this all good so far? All good so far? Excellent. So let's look at, this is, very contrived code. Like, in the real world, no one's ever going to say, hey, print out the numbers 10 through 14 for me, thanks, and I'll pay you money for that. So let's look at a slightly more interesting example. Reverse.c. Actually, if I make a file in gedit, will it respect the umask? Yes. Oh, cool. So let's make a new file. Let's save it as reverse.c. Copy all of my file stuff. Okay, and so what I want to be doing in this program here is I want to scan in some numbers and print them out backwards. So like if I scan in 1, 2, 3, 4, 5, print out 5, 4, 3, 2, 1. If we pretend we haven't just learned anything in the last 30 minutes, how could I do this in a really terrible way? If I want to get 5 numbers and then print them out in reverse order, I need to store the 5 numbers somehow, right? So int num1, int num2, int num3, int num4, int num5. Sure, I'm glad I didn't decide to print out 100 numbers. Scan into num1, 2, 3, 4, 5. Cool, and then what do I need to do to print them in reverse order? If I've scanned them in this order, what one do I print first to print in reverse order? Num5, very good. This might actually take longer than it will save. Printf num5. Cool, num4, 3, 2, 1. Very good, and so if this program works, it will make 5 ints, so just create 5 boxes for us, but separate variables, separate names, scan numbers into these 5 boxes, and then print those numbers out, but in reverse order. So the last one we scanned in was num5, and that's the first one that we print out. Who thinks that this will work? Who thinks that there's a problem in this and it won't work? What do you think the problem is? I don't think there's a problem, so if you think there is, then maybe there is. Making mistakes is very easy to do in coding. So if we type in 1, 2, 3, 4, 5, it prints out 5, 4, 3, 2, 1. Cool, that's roughly what we said to do. We probably should have had some spaces or new lines. Make those be new lines. Cool, and so compile our code, run our code, 1, 3, 5, 7, 9, and it prints out 9, 7, 5, 3, 1. Cool, now let's change this to do 50 instead of 5. How do I change this to do 50 instead of 5? I copy this. I'd probably actually write the code to do this. I've forgotten how to do Python. For I in, do I need the brackets in Python? I in range, what did I say, 500? Print scanf %d num plus I plus coding is really hard, you guys. Cool, okay. I'm getting bored of copying that. Cool, and then to print it out, I generate the same thing, but backwards. Oh, whoops, that should have been printf. And this, kids, is why we don't try and do all this stuff by hand. But I've already committed to copying it. I should have made that be like 200, not 500. Yeah. Anyway, you get the idea, right? This is a completely and utterly ridiculous way to try and make our code. One of the favorite tools in my arsenal, as like my toolkit as a programmer, is find and replace. But I don't think this will only do it in the selection. No, don't do it in the scanf. Undo. Anyway, this is, you get the idea. Okay, this is a completely and utterly ridiculous way to try and solve this problem. Completely and utterly ridiculous way, I tell you. Ridiculous. And I'll call the other one reverse silly, and I'll delete all of this crazy stuff that I just did. Okay. Cool, so those files are now there. So this is stupid, right? What's the point that I'm trying to make? What can we do instead of having 500 variables? Yes, we can use an array. Just a hint, if I ask, how do we do this thing, it's probably using the thing we just talked about. It's almost as if that's how I do lecture examples. Cool, so let's do reverse silly, it can be reverse array. Cool, so how do I make an array? It's going to be of type int. What do I want to call it? Nums, I'm going to call it numbers. How big do I want it to be? 500. Cool, so numbers, square brackets, 500 means give me 500 boxes all glued together of type int called numbers. What do I need to scan in all of these numbers? Yes, a loop. I want to do something multiple times. Why didn't I copy my code from before? Okay. So code from before, we said while I is less than 5, array I is 10 plus I. Well, we want to say while I is less than 500, array I is scanf. Oh, my array is not called array. Thank you. It's called numbers. And then to print it out, numbers. I kind of don't want to type in 500 numbers. Is there a way that I can, whoa, / reverse array. Is there a way that I can not type in 500 numbers? If you want to do something lots of times, what do? Use a loop. Cool, so rather than setting this with scanf in the loop, right, I could just go like numbers I equals I times 2, just for fun. So this will give me 500 numbers. What will the lowest number be? What will the number be in array slot 0? 0, cool, because 0 times 2 is 0. What will it be in array slot 500? It won't be because it doesn't go to 500, very good. In array slot 499, what will it be? Whatever 499 times 2 is, cool, very good. Cool. Was that backwards? This hasn't done what I wanted it to do. So what's the problem I have here? I wanted it to print them out in reverse order, right? But it's printed them out in normal order. What do I need to do to make them print in reverse order rather than normal order? Like I'm starting at array index 0 here, right? What should I be starting at? Yes, array index 499. So we'll make I be 499. Is this going to do what I want? I've said start at 499, don't start at whatever you're at before. Yep, so the problem is this will only do it once, right? While I is less than 500, 499 is less than 500, so it'll print it out, and then it'll stop because it's not less than 500. So instead, we must do a backwards loop. Instead of that, we're going to go while I is greater than or equal to 0. And instead of I++, it's I minus minus. Shocking. So this is going to do the same thing as a normal loop, but in reverse. So it'll start at 499. It'll decrease it to 498. Then it'll print out the thing at 498. It'll decrease it to 497, and so on. Reverse array. Excellent. We have printed out our numbers in reverse order. Good work, everybody. I think that was all I was going to do for this demo. Cool. So let's take a break. Before we do that, are there any questions? See, I said the words, let's take a break, and now you're all thinking about a break and not thinking about questions. If there are any questions, feel free to come and talk to me in the break. Otherwise, we will take a 10-minute break. Like I say every week, don't sit down the whole time, stand up, walk around, all those good things. That one there. So that is the beep of please return to your seats. The show is starting back. I hope you had a good intermission. Cool. So be quiet, please. Shh. That one's more effective. I think you must be trained in school, like when a teacher goes, shh, you just become quiet. It's magic. You should become a lecturer and do that. And anyway. So a couple of things. I had a question during the break. That stuff I did in the terminal with Python, do you need to know that? No, that's not in the course. That was just me trying to find a way to not have to type the code 500 times. So not expected to know that. You will learn it in future courses, and it's really useful being able to write in Python or some scripting language. So future courses, it'll be great, it'll be cool, but for now, don't stress. So there is a thing that I wanted to look at that I forgot before the break. So thinking back to our reversing array numbers code. Two things. First of all, this line here, this line sets I to be 499. Do we need to have this line? What is I immediately when it finishes here? Do you remember? Shall I make it be 5 instead of 500 so that we can see it all at once? Claire. Cool, so we did our number generating in here. Then we said print out I as whatever it is, I as 5. And then we print out the array in reverse order. Could we change this to be something other than setting it directly here? Like, do we need to have this line setting it to 4 specifically? What do you think? If I want I to be 4 and it's currently 5, what can I do to make it be smaller? Yeah, so I could do I minus minus. In this case, I would probably explicitly say I equals I minus 1 with a comment saying array starts at. With this very vague comment here, making me think of the fact that this got to 5 or 500 when it hit the end, and then when it hit the end it was 5, and we wanted to start from 4 or I minus 1 or whatever it is. So Okay, I'll just save the old version. I'm trying to make sure I get all the intermediate copies. Cool, so we decided we could just do this. So, in theory, first array v2. By the way, how many of you have been looking at the code on your laptops or whatever during the lecture that I've been saving? Has it helped you? Okay, I got 4 thumbs up. That's worth my time. I hope. Cool, and so when I run this, it does what we wanted before. It sets the numbers, prints out I as 5, makes I be 1 less than 5, which is 4, and then it prints out the numbers as we had expected. So I changed this to be 500 before, right? And so when I changed it to be 500, I had to change that one, and that one, and that one, but that's not needing to be changed anymore. When I have to change something multiple times in my code, what could go wrong? What mistake might I make? Like, I might miss one, right? I might make my array be too small or make this be too big or something. We have this fantastic thing in coding called hash defines, thus named because they have a hash and then the word define. And this lets me give a name to a constant, like a constant value, give a name to something. So in this case, if I go hash define number of numbers, that's not a useful name. Not entirely sure what to call this. It's the number of numbers, but that's a terrible... I'll call it number of numbers. And so what this line of code here means is it means when the code has been compiled, it does like a find and replace, and it replaces every one of these with this number here. So in our final code, this doesn't appear at all. This number of numbers goes away. But it means that in our code, that's just such a terrible name. I'm sorry, I can't think of a better name. Do you know what I could call it? I could call it array size, because it is the size of the array. Yeah, beautiful. And so what this means is that every time I have this word or this, array size thing written here, it will be replaced with 500. And so now if I wanted to make it be 50 instead, I just change this thing here once. Recompile, rerun. Cool, and now it is started at 50. Cool, does that make sense? Is that all good? Hash defines are really awesome and magical and we should use them all the time? Yes? No? Yes? So let's look at... I guess I'll switch back to the slides. They just have the stuff that I've already said. I figured it would be more fun to do it and then look at the slides. But it's written down if you want to remember it. Oh, hopefully you will remember it. So I didn't talk about this. So we declare an array called myArray with 10 elements. So myArray square brackets 10. This syntax here equals squiggle bracket 0 squiggle bracket means make all the values be 0. So this will automatically set them to 0 to start out with. So it's a cool trick. Again, sorry the diagram's broken. It's fixable somehow, I'm sure. To put the values into the array, so array index 0 we set to 3, array index 5 we set to 17. We'll ignore that one for a second. Scanf can't do an entire array at once, so we have to do one element at a time in the loop, like this, which we saw before. Printf, again, need to do them one at a time in the loop, can't just print the whole thing at once. To copy an array, I didn't talk about this one, but it's pretty much the same. We can't just say array 2 equals array 1 to make the array to have the values of array 1. We've got to copy them one by one. End of slides. Not the end of the lecture, but the end of the slides. So when we have an array, like the name array 1 doesn't really refer to the entire array as a whole. It sort of refers to how to get to the array. We'll talk more about that later on. But what it comes down to is array 2 equals array 1 does not mean the same thing as here's array 1, here's array 2, make this have all the same contents as this. Cool, so again, written down for your convenience. Andrew Taylor has his slides as well. You're always welcome to read both of our slides and see, who's got better slides. But in this case, our slides are basically the same. I may have copied his last year. Who knows? So let's do something slightly more interesting. Although hopefully this was slightly more interesting than it was originally. Oh no, try again. So I don't know if this is a thing in Australia, but when you're saying something and your friend says something at the same time, you say, oh, snap. So if we both say hello at the same time, I'll be like, oh, snap. Jinx, yeah, it's also Jinx in New Zealand, but it's also snap. Whatever. So let's write a program to do that, right? Let's write a program to scan in some numbers from the user, and then if the user enters the same number as before, print out snap. Yes. Hold that thought until week 8. There are good reasons that the question was, instead of array 50, why don't we insert thing you will learn in week 8 or 7 or something. I'm happy to tell you some of the reasons after the lecture. But yeah, Andrew Taylor has said, don't ask questions on the forum about stuff that we'll learn in 5 weeks' time, so I think that probably applies here as well. Anyway, snap. We want to scan numbers from the user and print snap if they say the same number twice. So let's keep our array size 50. Cool, that's fine. Can still be called numbers. So we'll make our loop be this, I guess. Rather than setting this ourselves, we want to scan this in, right? We want to get a number from the user. Actually, before I do this, let's just casually ignore all of this. Goodbye. So when I'm writing a program, right, when I'm trying to solve a problem to do something, and I'm sure I've said this already, I like to start out by working out what the steps are, and then writing the code to those steps. And I mean, with this program, right, I can do this sort of thing without having to think through it. I'm the lecturer, you'd hope I know what I'm doing. But certainly for anything more complex than this, I would do it myself. And for this sort of thing, I would hope that you will all do it as well. So what are the steps here? I want to take in numbers from the user, and then if they say the same number twice, print out the word snap. So the first step, right, is scan numbers from the user. I'm going to take in multiple numbers, so it'll be in a loop or something. And if we want to do the same thing multiple times, we need to use a loop. Okay, and then check if that number, seen that number before. And if so, print snap. Okay, does this look like the problem that I've said we're trying to solve? We want to get the numbers from the user repeatedly, so in a loop. And then for each number, check if we've seen that number before. And if we have, print out snap. So to scan numbers from the user in a loop, what do we need for a loop? And I equals 0, while something, do something, do something. This one's going to be I++. It's pretty easy, because it's the same as it has been every other time, except for the times when it hasn't been. So what do we want this condition here to be? While something. When do we want to stop our loop? I heard I'm going to assume that you said the right answer, which is when we get to the end of the array. Because we can't fit more than 50 things, right? So when we hit 50 things, we need to stop scanning. Well, I is less than array size. Okay, scan into an array element. I'm going to need to make an array. Actually, I sort of gave a spoiler. I was going to say, do we need to use an array for this? Why would we need to use an array for this? If you were trying to do this yourself, if I was just saying numbers to you and you were going to say, oh, you've said that number twice, what would you need to do with the numbers? Yeah, you'd have to remember them, right? And so to remember them here, again, we could make 50 variables, or we can make an array to remember the numbers in. And so that's what I'm going to do. So I've got an array called numbers. The size is array size, which in this case is 50. And we saw before, the thing I had on the slides but didn't show you is like this. Numbers array size equals open squiggle bracket, 0, close squiggle bracket. And this will set all the values to 0. Okay, while I is less than array size, scan in the number into numbers. What's going to go in here? If I want to scan in the current array, the thing into like the next array element, I, cool. Because I is going to be 0, then 1, then 2, then 3, and so on. And so we want to put it into array slot 0, 1, 2, 3, and so on. Excellent. So this will now scan in from up to 50 numbers, and then do something in here, and then move on to the next number and scan another number. So we want to be doing this bit here, right? We want to check if they've said that number already, and if they have, print snap. If I want to do something, check if they've done something, and if so, do this thing, what do I need? Yes, an if statement. If something, then print snap. Cool, what is the something? In English words rather than code. Or any other language of your choice. Yeah, like if it's a thing they've already said before. So we want to check if this number is one that we've seen before. That's probably a really complex if statement. So what if I just make that be someone else's problem? If we've already seen that number. So the number they've passed us in is currently stored in numbers I, whatever slot we're up to right now. And let's just make a function that later on someone else can write, whatever, not our problem, our code's going to be beautiful. If we've already seen that number, then print out snap. And then I++. So it's going to have to be our problem now to write this function. Oh, look at all this code from before. Goodbye. So the idea, my goal when I'm writing the main function is to make it be as clear as possible and so basically say what you're doing but not how it's happening. So in this case, I could have some really complex logic in here to see if I've already seen the number, but I could also just make a function and put the logic in that and then call that function. So now when you read through this code, right, while I is less than the array size, scan in a number, if we've already seen that number, print out snap, and then go to the next number. Does this seem good so far? Does the sort of idea of what I'm trying to do make sense? If you are very confused and sad, please put your thumbs down and look sad. Nobody looks sad. Fantastic. So, I need to make a function. I know that I want it to be called already seen and taken an input numbers I. What type is this input? It's an int. Yeah, this is one number in the array, like one of the boxes in the array, and so this should be an int. What type is the function going to return? What answer do we want it to give us back? Like yes or no, right? True or false? How have you seen in last week's lab to do true or false? Yeah, hash define them as numbers, and so return an int. What do I want to call this number? I'll just call it number. And so true 1, hash define, false 0. So now I could, for example, return true. Cool. So now this function will always say that it's already seen the number that they've given us. So in the main function, when it asks, have you seen this number? It'll say, yes. Yes, I have. Of course I have. Just believe me. Shall we run this and see if it works? Oh man. What did I forget to do with my function? Yeah, I haven't made a prototype. The compiler doesn't know what the function is. It can sort of like assume that I've given it a function. It's pretty smart. It's like, yeah, it's probably a function there. So it's a warning, not an error. But in this course, warnings are errors. Like if there's a warning, that means there's a bug in your code. So to make the prototype, I put it up here. I changed the open squiggle bracket to a semicolon. And now the compiler knows when it's compiling it, hey, there's a function called this, takes in this input, gives us output. Cool. GCC, compiles, snap. Okay, so let's scan in a number. Let's type in the number 5. Snap, already seen 5, okay. 10. 5 again. I think this program might be lying to us. I don't think it's actually seen this number before. I think it's just always saying true. That's a bit sad. And yeah, that's what it does, because we haven't actually done the logic yet. So okay, cool. We've established that we have written a loop, and it scans in a number. And then if the already seen function returns true, which is not the same as if it's already been seen, if the already seen function returns true, which hopefully means if it's already seen, but in this case it's lying to us, it'll print out snap. So that doesn't actually work. It just says true. What do we need to do to actually see if it's been seen before? Yeah, someone said loop over the array. In order to see, like to work out if I've seen this number, I need to think through the, look back through all the numbers I've already seen. And so, if I want to look through things multiple times, what do I need to use? A loop, a while loop. You guys can be more enthusiastic. If I want to do something multiple times, what do I need? Yay, some of you are enthusiastic, thank you. So, while something, do something, go to the next thing, and initialize somehow. Excellent. What are we going to want to have in here? Probably a loop counter. Probably int I equals 0, because it's always what a loop counter is. Cool. What do we want to have in here? Well, I is less than array size. Sure, let's do that. And then at the end, I++. Okay, what do we want to have in here? We want to see if we've seen it already, then do something. So, like if we've already seen this value, do something. Let's do it like this. Whoa, let's not do it like that. Let's do it like this. So the way that I like to solve this sort of thing is I start out by saying I haven't seen it, and then I look through the array, and if I have seen it, I update my have I seen it to be true. And then at the end, I just return whether I've seen it or not. So if I don't find it in here, it's already false, and so I'll return false. And if I do find it in here, then I'll return true. So if we've already seen this value, seen equals true. Excellent. So what do we want to do in here? We're checking if we've already seen number in this array. So in this case, we want to check through each element of the array as to whether we have seen the value number so far. So that means I want to start out by looking in like the 0th block, looking at the very first thing, seeing if the number's there, looking at the next thing, seeing if the number's there, looking at the next thing, and so on, right? So at this point here, I want to be looking in whatever the ith array slot is and seeing if the value is in there, right? Does that make sense? If you're confused, like who's confused? I feel like that was said quite confusingly. Okay, only a few of you at the back. Are the other people up the back always confused, or is it just like a coincidence? If you sat down the front, would you be less confused? Is that how it works? I think I'll draw a diagram for this because I think it makes way more sense with a diagram. HDMI projector 2, is that a question? Hold that thought. I will ask that question again shortly. Okay, go computer. So if we pretend that our array is like 5 big, because that's heaps easier than drawing 50 or 500, shh. Cool, this is our array of size 5. So let's just give them numbers for now. Let's say there's like 3, 1, 4, 1, 5, some random numbers. And let's say the number we're looking for is 4. So as a human, okay, now it says 4. As a human, does this array contain 4? Like, use your human brains and your human eyes. Is there a 4 in this array? Yes, there is, right? This is a 4. Can a computer do that? Can a computer just glance at this page and go, oh, look, there's a 4 on the screen? No, computers can't. I mean, maybe they can. Computers, the code we write in this course cannot do that, unfortunately. So we need to instead break it down into the most simple, straightforward, basic instructions. So in this case, that would look like, we start out by looking in this box here. Is this a 4? No, it's a 3. Let's move on to the next one. I'll make that a bit of a stronger color. Okay, look at this box. Is this a 4? No, it's not, it's a 1. Look at this box. Is this a 4? Ah, yes, it is a 4. We found a 4, so there is a 4 in this array. Does that process make sense? Do you want me to say it again? Make sense? Cool. And if that wasn't a 4, then we'd keep going. This 1 is not a 4, move on. This 5 is not a 4, move on. Oh, we've hit the end, so we haven't found it in the array. So in order to actually code this, this is, remember, arrays are counted from 0, so that'd be like array index 0, 1, 2, 3, 4. So if we were just comparing the very first one, the code would look like array, or whatever the array is called, 0. So it'd be something like if array 0 equals 4. Cool, does that make sense? This is how we'd look at the 0th element. And if we want to look at all of the elements in sequence, we'd start out by looking at the 0th one, then the 1th, number 1, number 2, number 3, number 4, and so on. And if we have a loop, where a loop counter starts at 0 and then goes 0, 1, 2, 3, 4, by looking at the array in the loop counter position, we then see whether that array value, in that slot, in the ith slot, has the thing we're looking for. And thus, hopefully this follows. We want to look in the ith array slot. So if I is 0, that's looking in this one here. If I is 4, that's looking in this one here. And we want to see if that is equal to the number we want. Number. My array is called numbers. Cool. And so, in theory, this does what we want. We start out by saying we haven't seen it, because we haven't, we've seen nothing. We start our loop counter at 0. While I is less than the array size, whatever that is, if the number in array slot I is equal to the number we're looking for, then yes, we have seen it's true. And then whether or not it's true, if it's found or not, we don't care, go to the next array element and look at the next array element. Cool. There are at least 2 problems with this. One of which the compiler will complain about, and one of which the compiler won't complain about. So let's start out by asking the compiler to complain for us. Before I run the compiler, does anyone know what the compile error I've got is? Did you say the numbers array doesn't exist inside this function? Roughly, yes. So the problem is, what happens inside a function stays inside that function, right? Inside the main function, we've made this numbers array. In the not main function, in the already seen function, this does not exist. It doesn't know about this array at all. There we go. And it's saying error use of undeclared identifier numbers. An identifier is like a name or something. So use of undeclared name of variable or type or whatever numbers. By undeclared identifier, the compiler means a user name numbers on line 44 of snap.c, which hasn't been defined. If you mean to use numbers as a variable, make sure to blah, blah, blah. Okay, thanks, compiler. So what do we do here? How do we solve this problem? Tell me a less technical and more Englishy version of that. So I think you're about to say this. Give the array into the function. Yes. So because the function doesn't know about the array, we have to give it the array somehow. We have to say, yo, here's the array. Here's the thing you can look in. How do we give something to a function? We put it in here, right? We pass it as a parameter. So some type, the name was numbers. What's the type of the array? This is a bit of a tricky one. The array holds ints, right? But if I had int numbers, that's just one number? No. Someone said an answer that is technically a correct answer, but not the right answer. I'm sorry to say no so harshly. We'll look at pointers in future weeks. So the answer here is we pass in the array like this. So we say, I'm giving you a number called numbers and an array called numbers. And just to be a good person, I should tell it how big the array is. I'll put this at the start as well. It's just nicer like that. So what I've done here is I've said, hey, I'm giving you a thing called numbers. It's of type int array. They're sort of on both sides, but this is saying the type is an int array, and the size of the array is array size. And so what will happen here is magically, this function now can look at this array. In order to pass it into the function, what do I need to put in here? So I need to put something in here to give it into the function. Can anybody think of what it would be that I pass in? I want to give it the array, right? Do I give it this? Whoa. Why is this not the right thing to do? Because it's got the int in front, right? Like when you type a printf, we don't say like printf, %d int I. We just give it the name of the thing. So it's exactly the same here. We just give it the word numbers, which is the name of the thing. Because remember, the type was sort of like int array, and then the name was in the middle. So this then will pass it in the variable, or the thing called numbers, which happens to be an array. And then the variable that's in numbers, it's slot I, which is this number we've just scanned in. So in theory, this will not work. Let's just run through this again as a bigger picture. So we start out by making an array of size array size, which we said was 50. Loop counter is 0. While this is less than 50, scan in a number into that slot in the array, so like into the 0 slot, then 1, then 2, and so on. Print out, why did we print out I? Does anyone remember? Was that important? Oh, I just typed that before, didn't I? My bad. Cool, and so scan in the number. If we've already seen it, so get the already seen function to do the work for us. If we've already seen the thing, print out snap, and then go to the next thing in the loop. And so when we have this bit here, this is saying call the already seen function, giving it these two parameters, one of them being numbers, the array, and one of them being numbers I, the value at array index I. And then in our already seen function, we start out by saying variable called seen is false, loop counter I is 0, while I is less than 50. If numbers I, so the thing in the array numbers at position I, which is different to the numbers I in here, because it's in its own little bubble. If that is equal to the number we want to find, seen is true. Otherwise, keep looking. Does this kind of make sense? Who is confused? The rest of you, are you not confused, or are you like confused about your confusion, or are you asleep, or like? Okay, so are there any questions about this that would make you less confused if I answered them? Is that a question? Do I need to initialize this one here? That is a very good question, and I was going to say that the answer to that question before, and I forgot, so thank you for reminding me. So when we call a function, right, when we say call our already seen function, passing in these parameters, this is equivalent to having like this in the function here. Something. So when we have this in our function signature, like in the thing that describes our function, this means that when we start our function, we have these two variables. One of them is int numbers array size that is equal to whatever we gave it here, so it's equal to this array here. And one of them is int number, which is whatever we gave it in the second thing, which is numbers I. So we effectively get these two variables for free. We don't have to write them here. That's given to us when we call the function. I'm going to put that in a comment because that is an important thing to not forget. Cool. Will this work? Does anyone think this will work? That's a mean question. I think this won't work. Do you think this will go through the array and look at all the numbers now? Like, have we achieved the goal of the mechanical goal of looking at all of the things? Shall I maybe put some printfs in there so that we can see what's going on? And this is a technique when you're writing code yourself and something doesn't work and you don't know why, add printfs. Printf is your friend. Printf's everywhere. So printf I is I. So by putting this here at the start of my while loop, whenever my while loop starts, I'll know what I is up to. Then I will printf here. The user typed the value at numbers I. This has already been printed out for me, printf snap, so I'll leave it at that for here. Then in here, let's print out hello from the already seen function. This might seem kind of silly, right? But it's useful to have printfs everywhere at every point to make sure that you know what's going on. Forgot to update. The prototype, thank you. So I made a mistake. Let's hold off on that mistake. I made a mistake and we'll see it later on when we compile it and it'll be great. So let's print out, we're in the function. Let's print out I in the already seen function is I. Let's print out here. Already seen this number. Okay, so what I've printed out here at the start, print out hello over in the function. Inside the loop, inside the function, print out I in the already seen function is this, so that we can tell it apart from this I printf over here. And then if the number is equal, say we've seen already seen number. Cool, and now when I compile this, it's going to complain about the fact that I don't have a prototype working. So these two errors, I'll make it full screen so you can see the beautiful errors. These two errors are like the same thing. I've made one mistake and I've gotten two errors. The first one is saying error too many arguments to function call. Expected single argument called number and have two arguments. And then it's saying conflicting types for already seen. So it's saying we've already seen a function of type, int function that takes in one int called number. But now you're giving me a new function called, already seen, returns int, takes in two numbers. And so the problem here is that I need to update my prototype. Because remember, the prototype tells the compiler, hey, I've got a function that looks like this later on. And if you lie to it and you say, oh, it looks like this and it looks like something else, then it goes, oh, you liar, you monster. Cool. I is 0. I'm going to type in 5. I'm going to make my array size be 10 so it's easier to see. Cool. And so you'll notice I changed the array size here, and now all of the instances in my program where I used the size, which was 50 before, are now going to be 10. Would have been really annoying if I didn't have the hash defined. Isn't it great that I have one? So here we go. The user's type 5. I'll try and actually, I'll stop that up here. So let's see if I can kind of point at both of these at once. So we're in our thing. We're in this loop here. We've said I is %d, and so we've said here I is 0. We scan in a number. I typed in 5. Then it prints out the user typed 5. We then call the already seen function, and then this goes into this function here and prints out hello from the already seen function, which is this printf we can see here. Then we go into our loop here, seen is false, I is 0. While I is less than array size, print out I in the already seen function is this. In this case, it's 0. So it's saying, I in this function is currently 0. If numbers I is equal to number, print out we've already seen it, and then seen is true. So it's saying we've already seen 5, so we're setting seen to be true. And then we look at index 1, 2, 3, da 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 da. Then at the end of this function, we return seen, which is true because we've seen it here. And we go, this is true, so we print out snap. Is this doing what it should be doing? Do we want it to say it's already seen 5 because I've just typed in 5? We don't, right? That's sort of, we could just printf snap for all numbers because you've typed it in once, and so we've seen you do it once, right? And so what is the problem we have with our logic here? I do actually want to draw another diagram. Has it gotten noticeably warmer in the last, 45 minutes? Okay. You have to turn the aircon on, and it goes for 2 hours. So someone else turned it on an hour before we got here. So if it gets warm, just yell out, Andrew, turn the aircon on. And I push the aircon button. You'd think that the aircon system would automatically work when there are people in the room, which is going to be 9 till 5, or 9 till 9, 5 days a week. Who knows? Okay, so let's make our array 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 7, 8, 9. Cool. So we have our 10 array elements from numbered 0 to 9. So let's look at what happens in our program. So we start out int I is 0, we scanf into numbers I, and so I typed in 5, and so 5 is going here. Right? All good? Do you believe me so far? This matches your views of reality? I hope. Cool. And so then I print out the user typed 5. I go to my already seen function. In this function, we start out by looking through the array. So I starts out at 0. So then we look an array element like index 0 if number 0 is equal to number. We've passed the number 5 into this function because we want to see if 5 is in the array, right? So we start out by looking in array index 0. This is always going to print true because we've found the thing that we've already put in there, right? So the problem with this is we're looking at things we've just put in already. How do we fix this, basically? What is the problem with this? I saw some finger spinning, and is that an answer as well? Nope. I heard quite a few things that may or may not have been the right answer. I don't want to be comparing this 5, right? I don't want to compare the 5 that I've passed in to the 5 that is the exact same 5 because I just typed it in to the array. Right? So I want to stop looking at look through the array, but stop before I look at the thing that I just entered. Oh, my move bar is cleared from gesturing my arms. Very good. Such good exercise, waving your arms around. So for example, if I already had some numbers here, just to pretend or make this example clearer. So I've just scanned in 5 at this point here, and I want to see if I have 5 in this array. All right, so I is going to go through, is that recording? I think it's recording. I is going to start at 0, look at 9. 9 is not 5, so it'll move on. It'll look at 3. 3 is not 5, so it'll move on. It'll keep looking through. It'll then compare it to the 5, which is the 5 that we just scanned in, which we don't want to compare it to. Then it'll say, yes, I've seen the 5, and then go, cool, we've seen the 5 already. What do we need to change about this? When do we need to stop looking at the array? Tell me that in words rather than code. Yeah, so everything other than this bit here. We don't want to look in this one here, we want to look in the other ones. So we can take that even further. We can say we just want to look in the ones before it, because if we've just put the 5 in, there won't be anything after it. So if we want to stop when we've hit this point here, right? Shh. We're going to look through our array, and we want to stop looking in the array when we have hit a number. Sorry, stop looking in the array before we hit the number we've just scanned in. So in the case of this diagram I've got here, we've just scanned into array index 4, and we want to not look in array index 4. So what do I need to do? When do I want to stop here? What should this, rather than going into the whole size of the array, why I is less than 1 before the one we are up to? How do I actually get this into my function? I want to pass it in right. I want to tell it where I'm up to. So let's take in an int here. So let's say int up to, and let's have this be the position in the array that I'm up to. So for example, when I've just scanned in the 5 in this example I've written down here, the up to would be 4. Okay, and then I need to pass that in here. So what is the value that I'm up to? Like, what position am I up to? I. Cool. So this is now going to say, when I call the already seen function, here's the numbers array, here is the number that I'm looking for to see if I've already seen, and here is the position that I'm up to. Here's like the loop counter for where I'm up to in the loop. Cool. And then while I is less than 1 before the number we're up to, we actually want to see, we can say if I is less than up to, and that means I will stop before it is equal to up to. If that makes sense. Like if up to is 4, I will be 0, 1, 2, and 3, and then not 4. It'll stop before it is equal to 4. So to go and kind of go over that again, it's all the same thing as before. We have while I is less than the array size, go through the array, scan something in. But then when we call our already seen function, we also tell it the position we're up to in the array. And then in our already seen function, we look at scanning, like looking through the array up until the position we've just scanned into. So, someone said I need to change my prototype again. Oh man, you guys and your prototypes. Int up to. You just like the compiler nagging me about prototypes. Cool, so it compiled. Snap. So if I enter 5, cool, the user typed in 5, hello from the already seen function, didn't say it's already found it, which is good, and then it said I is now 1. So we were at this point here, I was 0, the user typed in 5. We went into the already seen function, we printed out hello from the already seen function. We didn't print this out here, because we were going until we were up to like less than position 0, which we were up to. So 0 is not less than 0, so we didn't look at this at all. And then we returned seen, which was false. Okay, now if I type in 10, the user typed in 10, hello from the already seen function, I is in this thing's function is 0, I is 2. If I type in 5, the user typed in 5, blah, 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 blah. We've already seen it, snap. Cool. Let's turn off our debugging print so that it looks more impressive. Okay, tell me a number, someone. 7, 32, 42, 7, snap, you've already said 7, 7, snap, the letter A. Oh man, you suck. You ruined it for everyone, man. Let's try that again. /snap. Okay, so let's just type in some numbers. 5, 4, seen already, 3, 2, 1. So before we go, one more thing that's really cool that I want you to do. Please pay attention for 3 more minutes. Let's change our loop so that it stops when we see one we've already seen. So I'll have a scene in this main function here. If already seen, print out snap, scene equals true. And then make our condition be while seen, while not seen. What this means here, while not seen. So while seen is not true, which is false. etc. Cool. 1, 2, 3, 4, 5, 5. Snap. What happens if I keep on going? 5, 6, 7, 8, 9, 10, 11, 12. Hang on, what? Shh. Shh. 2 more minutes, probably 1.5 now. What's happened here? So I typed in some numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I typed in 11, I got a bunch of equal signs. I typed in 12, and I got a runtime error. Illegal array pointer or other operation. Those are words you'll come to know very, very well. But let's ignore this. Let's be cool kids who don't use DCC. DCC is nice, and it'll tell you, hey, you've done something wrong, you shouldn't have done that. Let's use GCC. GCC won't stop you from doing things wrong. 6, 7, 8, 9, 10, 11, 12. Okay. Why did that stop? I was hoping it would crash. It didn't crash. So looking quickly before we go, before we run out of time, look, an interesting thing happened. Why did it happen? So specifically, this should have stopped.